Okay, welcome to this video. So we now getting a grasp of this concept of continuity, and we can continue more with it. Remember, a function is continuous if the limit from the left at that particular point equals to the limit from the right, and it's also equals to f of that particular point. So that's what we can do. Now, another miscellaneous type of question looks like this. It therefore says determine the values of p and q such that the y, which is our piecewise function, is continuous for all values of x. Okay, so now this is a different type of question, and I'd like us to have like a more open-minded approach to this. So what we need to understand here is that we can understand this by drawing this particular diagram here. So let's see how we'll be able to do this. We can do this here. We have these scenarios. We've got what happens at -1, what happens between -1 and 1. So these are points. So what happens around these 2 points here? So we can clearly see if we're approaching -1 from the left, the function that we then meet up with is the function x minus 3. And then in between, we've got this function px minus q. And then on the other side, we've got this 2x minus 5. So let us see how we'll be able to do this. So what we understand is that if we are approaching this -1 from the left, we'll have the limit as x tends to -1 from the left. We essentially bump into this function, and if we take the limit of that, we get -1 minus 3, therefore giving us -4. So that is the limit from the left to -1. So if we go into -1 from the left again, we'll now have the limit of x as it tends to -1 from the right. So we now meet up with this function, which is px minus q. And if we then substitute -1 there, we end up with minus p minus q. So that is the solution that we get there. Let us continue to the next function there. So therefore, we know again, if we're going to approach 1 from the left, we're going to have the limit as x tends to 1 from the left. We do meet up with this function again. And therefore, if we take the limit of that, we substitute 1 where x is, we get p minus q. So that's what we get when we're going around 1. Another thing that we want to do is we want to approach 1 from the left, from the right. But we now meet this function. Therefore, when we get to this function, we get 2, 1 minus 5, therefore giving us the answer of -3. So now we understand that for continuity to hold true, right, for this function, because we want to prove that it's continuous everywhere, we want to prove that this function is continuous everywhere, we need to actually we know that by the definition, when you're approaching any number from the left and right, those numbers should be equal. So from this first part here, we are able to get that -4 is equals to minus p minus q. And that's what we know from continuity. And then also we know that this statement over here must also be true. So from here, we know that because of continuity, p minus q must give us -3. So therefore, what we then want to do is simply solve for p and q. So we now have a simultaneous equation, 2 variables. What we'll do, we'll start simplifying this one over here. We can simplify this by taking, I'll use the radical by taking the 3 across, the q across. Now this becomes -3 plus q. We will then come in and sub it into that one. So this is -4 equals to, wherever we find p, we'll substitute -3 plus q minus q. And therefore, when we're in this particular situation, we can distribute the negative in. That becomes +3 minus q minus q. And therefore, from here, we are able to take the negative across, giving us -7. Therefore, this gives us -2. And therefore, from here, we are able to get that q is equals to 7/2. Then what we'll do, we'll sub in back in there and try to get what our p value is. We get p plus 7/2. And therefore, we can quickly work that out by either plugging it into your calculator or just merely simplifying what that gives you. And when I do work this out, I get that my answer of P is just a half. So this is quite the nice miscellaneous type of question on continuity. I hope this has made sense, and therefore I shall see you in the next video.